Hi everyone. I'd like to start by acknowledging the traditional owners of the country that we're meeting on today and of the Great Barrier Reef and its catchments, and pay my respects to their elders past, present and emerging. I'm Cameron Fletcher and I lead the response sub-program of the COTS Control Innovation Program. And one of the bodies of work that I coordinate relates to research designed to help managers and on-water crews in the COTS Control Program make ecologically informed decisions more effectively. These include decisions like where around a reef to drop cull divers, when to invest in monitoring and when to change management strategy based on the data that they're collecting. Today I'm going to tell you about the next generation decision support platform that myself and a group of researchers across multiple organisations, including JCU, CSIRO and Gurumpa, have developed as part of the COTS Control Innovation Program. The platform integrates multiple components: an information system to coordinate and share data, automated digital workflows to process that data, empirical analyses to adaptively update key control program parameters, and decision support tools that put the outputs of these efforts right on the screen in front of decision makers at Gurumpa and on water at the moment they're trying to make those decisions. This is tied into a number of projects within the COTS Control Innovation Program and also the ongoing innovation in the operational program that's been driven by the Great Barrier Reef Marine Park Authority. So the platform starts with the CSIP information system to underpin the sharing and distribution of field-derived and modelled data between the control program, CSIP researchers and on-water operators. This is designed to increase efficiency, but also to supercharge innovation across CSIP by making both data and models easily shareable and reusable. That way, if I come up with a better way of estimating COTS density today, my colleagues at UQ might be able to incorporate that into their reef scale modelling next week, and it might be improving decisions being made at Gurumpa next month. It also provides a direct path for results, path to managers for research results from across the COTS Control Innovation Program. So the information system is work that's been led by Oman Rezvani from CSIRO and myself. We designed and built the information system to provide a federated data store, fully searchable metadata, a process register to track provenance of models, and to track models, and a provenance system to track how that derived data was being generated by those models. Our system incorporates ideas that you will have seen in the RRAP Modelling and Decision Support Information System, and it's also aligned with the RIMREP Data Management System. But it's a quick and lightweight version built on the Microsoft stack, so it's integrated into Teams and it can connect into the PowerBI dashboards that Gurumpa use to inform decisions in the COTS Control Program. One of the reasons that an information system is important beyond efficiency is because it enables innovation multiplication through reusable digital workflows, where input data that flows into the information system is automatically processed to become the intermediate and output data that researchers and managers need. The simplest example of this is just the way that we clean COTS Control Program data as it comes into the system. So this is a task that we used to do manually, but as the program and the data it's collected has scaled up, that's become a bottleneck. To resolve this, Ethan Waters at JCU has implemented a cutting-edge data cleaning system as a reusable digital workflow that sits within the information system. So every time a new tranche of COTS Control Program data gets put into the information system, the reusable workflow runs, automatically generates the clean data set, uploads it to the information system along with the metadata and the provenance information that's required to understand it and make use of it. So that's a simple example, but the same underlying process enables more complex things like running algorithms to assign man to toes to sites or estimating COTS density from control program data. It also forms a foundation for more advanced analyses, such as the way we are adaptively optimising the control program structure by empirically analysing data from the control program itself. This is work that Carla Yules at JCU has been leading. She's provided a couple of empirical analyses, but I'll just highlight two here. The frequency with which we need to re-man-to-toe reefs to make good decisions about where to drop divers, and how we can estimate how much effort a reef should take to bring down to the ecological threshold. These both represent adaptive management based on empirical analysis, in the sense that When we designed the ecological underpinning of the control program back in 2018, we had to make a few simplifying assumptions and take a few educated guesses at reasonable parameters for that system. So one of those was that each reef would need to be mantitoed every fourth voyage, or roughly every 50 to 60 days. And another one was that once we started culling at a reef, we would keep going back to that reef until the job was done, no matter how that transpired. Both of those decisions were based on our best knowledge at the time, but we recognised as we were designing that system that once the control program was running, it would start collecting the data we needed to actually be able to make those decisions scientifically and optimally. And so that's what we've been doing now. Colours produced an analysis that shows how the quality of decisions about which site to cull at next around a reef declines with the time since the last mantito at that reef was conducted. As you'd expect, the prediction gets worse with time, and then Colours calculated how that affects the quality of the decisions that are made. How often does it lead to the wrong site being selected next for COTS control? With the time since last mantito, which then informs when you need to do a new mantito so that your decisions are as good as they can be. It's more complex than that simple cartoon makes it look. The answer depends on ecological characteristics of the reef, how recently sites near the site that you're most interested in have recently been culled, and the overall proportion of sites at the reef being culled. And so it's built into a decision support tool that Gurumpa can use to make informed decisions about when a reef needs to be remantitoed. Colours also produced an empirical analysis of the amount of time we would expect a reef to take to be brought to the ecological threshold when we first arrive at that reef. This is important because although most reefs are relatively well behaved, occasionally the control program encounters a reef that seems to take forever to reduce to the ecological threshold. And when we just persist at these reefs, they soak up a huge amount of resources and prevent us working at and saving coral at other nearby priority reefs. So Colours produced a statistical model that for each reef that the control program visits takes a few key ecological characteristics of that reef and the initial densities during mantito and the first culls conducted at that reef, and estimates how much effort it's going to take to bring that reef down to the ecological threshold of COTS density. That's important because it'll help Gurumpa make decisions both about that help them sequence their operations on water if they know how long they're going to have to be working in a given location. But more importantly, it's going to help them identify when a reef is not behaving as you would normally expect, and to use that information to either change their strategy or redirect those resources to other nearby priority reefs. So all that data sharing and reusable workflows and empirical analysis is great, but it's not useful until it makes its way back to managers where they can use it to make more effective decisions. This is exactly the role that Ethan Waters, with a different hat on, has been filling for the past 6 months as our research translation lead in CSIP. He's been working across 3 organisations now, Gurumpa, CSIRO and JCU, and he's been working closely with the other CSIP partners. He literally comes and sits with me 2 days a week at CSIRO, and then goes and sits at Gurumpa 2 days a week with Sam Matthews and the COTS team. He's connected research outputs from the information system sitting on CSIRO computers to the PowerBI dashboards sitting on the desktops of Gurumpa computers in front of decision makers as they're making decisions. And then he's talked to them about them, and then he's tweaked them to make sure that they're presenting the information that they need to make the decisions they need to make. So this has been crucial for creating a direct path to impact for CSIP research, such as putting the outputs of the regional or GBR scale modelling scenarios on computer screens in front of Gurumpa decision makers and allowing them to then interact with the outputs so that they can understand and interpret the results. So this is work that comes out of project CSIP-R-04 that Tina Skinner from UQ and Scott Condy at CSIRO have used GBR scale ecosystem models to look at different distributions of the COTS fleet across the GBR and look at the long-term trajectories of coral cover in response to those different strategies. And then there's another dashboard which isn't shown here from Gabriella Schaffelle's work in CSIP-R-06 that looks at the cost benefit, the cost effectiveness of these different strategies. So these dashboards are focused on the decisions that managers need to make, generally in the relatively near term. And sometimes a single CSIP project provides that information. Other times we need to combine the outputs of multiple CSIP projects and other data sets from across the GBR. So a good example of this is the early warning system that Sam Matthews at Gooroompa has developed and Ethan is now helping extend. And this brings in new monitoring methods being developed by Morgan Pratchett and his team at JCU, and Sven Yuthicki and his team at AIMS, connectivity modelling data being produced by Severin Shukran and Mike Bode at JCU and QUT respectively, alongside other data sources such as the QPWS Field Management Program and AIMS Long-Term Monitoring Program data. The tool aggregates and synthesises data streams to assess primary outbreak risk and help managers make decisions about where to focus effort in response to new outbreaks. Finally, we have our on-water decision support tool. Simply put, this takes all the control program data collected up to yesterday and helps on-water crews make decisions about where they should drop divers in the water today. The tool uses a hybrid architecture that combines cloud-based historical data sharing with local cleaning and integration of voyage data. It runs a COTS density estimation module and provides a platform-independent user interface that can run on tablets or laptops to provide decision recommendations to on-water crews. Like everything else I've been talking about today, the tool is of use in and of itself, but the real power here is that it's connected into this decision support platform extensively. So it's connected to the information system. It reuses code from the reusable digital workflows, and it is modular, so the COTS density prediction algorithm can be updated remotely as new research improves our ability to make predictions about where COTS are likely to be around reefs. For instance, there's a talk in about an hour in one of the parallel sessions where Zahid Islam, who's a research scientist that I work with at CSIRO, and I have developed machine learning methods of predicting COTS densities around reefs without requiring mandatos. So in future, we could integrate that workflow into our algorithm and push it to the decision support app seamlessly. So that's the integrated platform we've developed for information sharing and empirical analysis to innovate decision making for managers and on-water crews in the COTS Control Program. Right now we have all of these components built and we're in the process of rolling them out. The platform approach I think is important because it provides a direct link between the control program and researchers and then back to control program decision makers. And it provides a direct path to impact for the 20-something other CSIP projects to managers. It helps coordinate efforts to multiply innovation across a large multi-organisational research program by promoting science and code reuse and collaborative connections. And I think probably one of the really standout successes has been Ethan Waters' role as the research translation lead in the last 6 months, which has really allowed us to target and interpret and fine-tune our science outputs to exactly the information that managers need to make their decisions. So my hope is that this kind of collaborative, decision-focused platform approach will continue to underpin great decision-making for the COTS Control Program and hopefully be extended for other challenges on the GBR. Thank you very much.